In this lecture, we shall try to learn one very old concept in Java to store a collection more compatible way, and this is called class vector. So, our today's topic is how an array or a collection can be maintained using a class vector. The vector class, like other collection, as you have already learned in the last few lectures, it is defined in the java.util package. Now, our today's topic includes a basic introduction to vector class. Then there are several operations, those are possible on this class, namely how to create a vectors, how insertion, deletion and other necessary operation like searching and then copying and everything can be done with this class utility. Now, let us see exactly what is this, this vector class is basically. Now, vector is okay. Now, you know Java programming is almost 25 years old, but from very beginning the programmer was comfortable with one class. This class is called vector, and in addition to vector there are few more classes are there like dictionary, hash table, properties, stack and everything. So, all these classes were to manipulate data structures actually, but later on the Java developer thought that there should be some more what is called more efficient way all those data structure can be managed, and they introduced the collection framework. So, this is around JDK 5 and onwards, but prior to JDK 5 all those classes, they are called legacy classes, were known, very popularly used. This like Java collection framework, these legacy classes also defined in java.util package. Now, they are called legacy class because they are still in use. In fact, if you see Java collection framework, they are built on based on this legacy class only. So, legacy class people say that they have been deprecated, but if you want you can use, but Java developer do not recommend to use them in the new code that you are going to develop, because more smarter utilities are known. So, why you should use the old things are there, but still if you can write program and use those class, your program will run successfully, it will compile also, no issue. Now, what I want to say is that all those legacy classes were used or have been used to build today's Java collection framework. Java developer use those legacy classes to build the new Java collection framework in fact. So, that is why the class has its own importance. So, today we will discuss about this class vector. Let us first start about the vector class actually. Now, if you see, we are discussing about array. Array is a linear collection. So, if you want to store set of numbers or strings or some set of objects of type say student or whatever it is. So, they are basically arrays of collection. Now, vector is nothing but an array of collection actually, but it names vector, and you know, if you know mathematics, then the concept of vector is there. So, vector is basically is an element, or you can say quantity which has number of components, or you can say number of dimensions are there. So, a vector, for example, in a 2-dimensional vector consisting of 2 components like x and y. So, usually we represent a vector say A is equals to I x plus j y, where x and y are the 2 components along 2 axes, I axis, j axis, like this one. Now, here the vector comes that way because it also has a number of components. Actually, our objective in Java programming is basically to manipulate objects, and if you consider an object in fact a high dimensional things actually. All the fields that is there in an objects, or we can class definition, they are basically is a components. So, if a student has field say name of type string, integers type say age, roll number is another string, marks is float, then we can say there is a 4 components. So, 4 directions. So, w, x, y, z like. So, this is a vector. So, that concept comes here also. So, vector is basically meant for storing objects very nice way actually. Now, there are few more things about the vector which is very interesting, like other collection framework that we have studied. So, we can create a vector. Vector is a collection of objects, we can say right now. Now, if we create a vector, so whenever we create a vector, this vector can be created with an initial size of it. So, that is called the capacity of the vector. So, initial capacity. Now, so actually all the collection that is required in a programming, it should be dynamic in nature. That means, whenever you decide that this is the vector of size say 10, but later on you thought that okay, no, the size should be 100 or more than that. So, automatically there is a need to grow the vector or size of the vector actually. So, a vectors you can create initially with some initial size of it, and later on if you want to increase it, automatically it will increase, where the programmer does not have to do anything. That is a great advantage of this one. So, automatically it basically allocate the memory space to fit with the more objects that needs to be stored in a vector. So, there is a memory requirement. So, from the memory requirement, the efficient memory management is not at all the headache of the programmer. This is a great advantage. And there are many other issues which basically very elegantly have been implemented in this vector class realization, that is basically called the automatically incrementation. How it will increment depending on your memory, depending on your speed that is required to run an application, you can increment either slowly or in a very fast way. So, that increment of the size also can be controlled. For example, initially you can decide a vector of size say 10, and later on you want to increase it by say 10 each time, or say 20 each times, or 5 each time, that you can control, it is there. So, these are the things that is very important. And another most significant things which basically differs this vector compared to the other classes there in the Java collection framework is called the synchronization. So, actually the vector is basically suitable for multi-threading or multi-programming program writing, and where the thread is required and thread can run parallelly. So, if you want to maintain many collections and all these collections you want to share among the different threads, so the thread safe execution is possible with vector class, which is not possible with other collection framework classes like ArrayList or arrays like this one. So, these are the very nice things there. That is why vectors is still popular among the programmer because of those features actually. Now, let us come to the discussion about operations with vector. Now, there are many operations are possible. So, here I list different operations that you can apply on the vector objects. So, creating a vector, this is the basic operation that you have to how to create a vector of your own to store your own objects. Then inserting an element into a vector, removing an item from a vector is basically deletion operation, accessing a vector and its content. So, we can access the vector in a different way. So, we can access the vector at a particular location or at the end or at the beginning. So, there are things are there. So, all those things are built in there. So, you do not have to write the code for that, only you have to call that what you want to do. And in addition to this thing, there are some bulk operations. So, it is basically operation on a particular element and operation as a whole. So, bulk operations. So, all the bulk operations also can be possible on vector classes. So, we will discuss all those operations in this lecture. Now, let us first discuss about how you can create a vector. So, creating a vector means an instance of the vector object can be and there are four constructors. I have listed the four constructor here. As you can see, the first constructor is called the default constructor, which does not require any arguments. So, this basically creates a vector of an default initial size. So, default initial size is 10. The another constructor which basically allow you to define a vector of a initial size. So, initial size is an argument int, so that you can decide. The second vector, another important argument is there. In addition to the size in the second constructor, it basically add another argument called increment. That means, each time if the vector has to grow automatically, then by which size that it will increment automatically. So, INCR is there. So, initial size may be 100, and if you specify INCR value as 25. So, each time whenever a vector is filled and you want to add few more elements, then it automatically grows by 25, then 100 to 125 and so on. And then the last constructor is very useful. If you have already collection at the moment you want to create a vector, then you can pass this collection as an argument, and a vector will be created initialized with the all elements in the collection. This collection can be anything. This collection may be dictionary, this collection may be arrays, or any other things are there. So, these are the different constructors that is there in the class vector definition, and you can use this constructor to create your vector. Now, so this is basically, let us see some examples. So, you can understand about how this can be used, and this is a very simple example. I made the example very simple, so that you can understand at the very first hand. So, this basically, okay, as you know, this is defined in java.util. You have to import in every program if you want to use the vector class. And here you see I used the default constructors. So, V is a vector is created whose initial size is default size, that means size is 10, and then few next statement, as you see V, that means this is the vector V, and then dot add means the add method. Add method is defined there in the collection, you know, this is a standard method that how you can add an element into a vector. So, with this statement actually starting with vector V is initially empty, and then add elements one by one. So, initially empty, and then next element 1 is added, 2, and here you can note this is another object is added. So, the name of the object is a string here, this is the double value, another string, it is there. So, we have performed in this example 5 add operations, is basically to initialize the vector V that we have created here, and you can note this statement is very simple statement, the printl statement. Actually printl statement print this. Now, here this V, actually here one thing you should note that all this 1, 2, now it is string, the double. So, these are the type of different, I mean values of different types, actually elements of different types, no issue, because the vector will store them as a string format. And here whenever you print V as an argument of the println statement, system.out.println, it basically convert all the collections of all elements into a string and it will print. So, it will print basically 1, 2 and Devashish 3.4 Samantha, like this one. So, this is a very simple example that you can understand that how a vector can be created, and the vector can be initialized with few elements like 5 here in this case. So, okay, so if this is a very simple example, let us consider one more example, little bit okay, moderate level of codes are there. So, in these examples we want to demonstrate that how a vector, if you can create, store the different type of objects. Now, we are storing objects actually, again we will consider very simple object like integer objects. Now, here if you see an object 1 is basically the value, and if we pass this value to a class integer. So, basically is a constructor integer class is defined in Java or Lang package, actually there are many. So, object a number can be created into an object form either it is an integer or string or double or float or whatever it is there. So, this basically 1 is an integer value and we create an object of this value by using the integer class actually. So, this new integer 1 is basically is an object version of the integer 1. Okay, fine. Now, here let us see how we create in this example using the third constructor that we have discussed. Here as you see the two arguments we have used. The first argument is basically the size and the second argument is basically the increment. That means, initially the vector of size 3 and then increment is decided by 2. So, each time if the vector is already full, then it will increment automatically by size 2. Now, let us come to here. So, these are the two basic statements that you can call for this object B, size and capacity. So, what exactly the size? It says that what is the total number of elements are there, and capacity is basically says that what is the total number that you can load into the vector. So, in this case both the value the size is 0 initially and then capacity will be 3 like. Now, if you go on adding, but here we will add elements or objects using some other method, not the add method. Okay. So, here add element is basically adding an object into the vector V. So, we use the add element, that means inserting some element into the vector actually. These are new methods that we are using here. And so, here we see add elements have been called for 4 times into the vector object V, and all the elements that is added there 1, 2, 3, 4 like this one. But here if you see when you come at the point at this point, so vector is already full because initial size is 3 and then we are going to add another one element. So, automatically the vector will be increased by size. So, at this point after loading, whenever you want to, when you attempt to add one more element, namely 4 there, so vector size will be 5 like. So, if you print the V dot capacity, you will see that it will print 5. Now, after adding element, absolutely no problem, vector need not to be, because it will can accommodate the new element because size is 5. So, it will be capacity 5 also, it will store this one. So, we have understood about that how automatically the vector can grow as the number of elements or the elements go on inserting into the vector, and it is absolutely not an issue for the programmer that you have to manage the memory and then accordingly arrange it. Okay, let us continue this program again, few more insertion carrying on, and then automatically as the vector can grow, you can see it. I am adding more elements here. This is another object double, integer 7, float. So, any type of objects here, if you can create your user defined object like student type also you can do, absolutely not an issue there. Now, so up to this part, as we see, we have added a large number of objects into the vector V, and vector automatically grow its size, as by the printing of this we will be able to see it. Now, let us come to the few more interesting methods, namely the first element and the last element. As the name implies, you can understand that. So, if we call the method first element for the vector V, so it will basically access what is the element at the very beginning in the vector, and in contrast to the first element, last element basically, which is the last element in the row of vector. So, is a first element, last element that can be accessed from the vector and can be printed, and as this is a first element should be integer form because it is already stored there in a string. So, that is why we have to casting this type by integer because they are integer. So, casting is important because in which form you want to store, because if you create a double value, so you should cast as a double, that this element if you want to print for example. So, you can similarly if you want to print a string, then you have to cast into string like this one. So, casting is important. And here is another method, the contents method. We will discuss this content method again later on. So, this method is basically check whether a particular element present in the vector. For example, the contents is a method, arguments is 3, that means this statement actually what it does is basically check whether integer 3 is present in the existing vector V or not. So, if it present, it returns this contents return true, and if it does not present it will return false, and if it is present true, so it will print that the vector contains the number or objects. It is like this. Now, if you want to print the entire vector, we have already learned about how it can be done using simple println statement passing the vector as an argument, but there are some other, it is called the iterator. So, enumerator is there. So, using the call of enumerator you can call it. Here actually you have to declare a enumerator object. This is basically that elements of the, so v dot elements indicates that it is an enumerator, that means I want to count or enumerate each elements in vector, and then it basically go on printing the elements. So, that for this basically this is basically scanning one after another. So, has more elements, that basically it is starting from the beginning and go to the next and so on, and it will basically print the elements actually. So, next element. So, here, so while this basically continue till the vector is not come to an end, and it basically print each element whenever it is scanning, and it will basically print. So, this way it is print. So, this is a very one structure code you can follow, you can practice of your own later on, and you can see exactly how it works. So, it basically scan the entire vector and print each elements in it. This is one another way many programmer prefers it compared to the simple println statement, because there are no customization, no control over how to print, but this element you can use, you can print in one row, one column, or 3 elements in one rows, then so many columns, so many ways that you can. So, that is why this has its own advantage. So, this is the one example that you can study, that how vector can grow automatically, and then vector can contains many elements in it of different types, and all these things can be stored as an object. So, this is the idea that I want to convey it. Now, let us see, there are some other operations we have already learned about. Few operations we have learned like add, and then add elements, then contents, then first element, last element. Now, regarding insertion specifically, there are few more operations are known, very popular, they are very popular for this class. They are basically add element. We are already have an experience about the add element method in the last example, and in addition to this add element method, there is one method is called insert element add. As the name of the method implies that you can insert a particular elements at a particular location of a vector. Now, here if for example, in an array if you want to insert at a location say 10 where the size of the array is 5, then definitely it will throw array index out of bound exception, an error. But here in case of vector, you have created one vector of size say 10 and you want to insert at element say at 20, absolutely it will not an error, because it will automatically grow to accommodate the element in a particular location, although the different locations remain vacant before this, because you are jumping into some location without filling the elements. Anyway, so this is the one, these are two methods that you can think for inserting elements into the vector, in addition to the very primitive methods add. Add is always there to add any objects into a particular collection. Now, let us see how this method again can be exercised with an example. So, this is the third program you can consider how insertion of elements into a vector can be done, and as you have see as you see here, this is the add method we have called for this. So, add 1 2 3. Now, in addition to the add, we can use the method add element also. Add element will automatically add at the end of the existing objects actually. So, if we call add 5 without mentioning where to add, automatically it will add at the end of 4, that means till time this one. So, it is basically grows sequentially. Now, here in this here we call insert element at. So, as you see, we want to insert the element says insert the element say 10, we want to insert 10, but at the location 7. Now, here you see, so this basically element is stored at one location, but 0 is there. So, 7th location if you say, so index 7 is here index 7 is basically this is basically 7th index. So whenever you call this index, so this one insert element at 10 7, it will basically come to that. So this automatically make an arrangement so that this element will be moved one place towards down, and it will make a space for the element to be loaded here. So whenever it is there, it is not that it will overwrite, it will basically whatever the movement in the existing element is required, it will do it and then make a place for that and automatically adjust that place to fit into there. And this is a simple vector printing. So we after doing this one, if you want to print it, then you will see it will print the entire vectors. So this basically shows that if you can insert any element at any, you can insert any elements at any place in the vector, no issue that vector will be overwritten or it will lose some data, it automatically make an adjustment to accommodate the newly inserted element into the vector. So this is the insertion beauty, that you can do it without any headache of your own, and it will do automatically everything. Now here another example. So again inserting element, and here you can see this example has little bit difference compared to the previous. Just now we have learned the example here. Now add element has the two polymer methods. So initially if you say add one, it will add the element at the current location. Now here if you specify at which location you want to add, so the second argument, the first argument says that in this method add, the first argument says that index, and then the next argument says that what value that needs to be inserted there. So here 1 needs to be inserted at the location 1, 2 is at the location 2, this is another string at the location 0, that means index 0, and so on so on. So these are the first argument, so that at what position you can do it, and at any order you can do, it will do it absolutely that way. So index wise insertion that can be there, and this is the example that we have already insert element at this way. So you have learned about how the elements can be inserted into a vector in a different way. We have learned many ways of inserting elements into the vector. Now another, the insertion operation where you want to insert a set of elements, but in a appending mode. Appending means vector is already contains some elements and you want to add after that, and then this is called the appending. Now let us see one example how the appending, that means adding some set of elements into an existing vector can be carried out. And here is an example you can see. First we create a collection called ARR, is a collection of type array list. Array list we have already learned in the previous our lessons. And here, so these are the basically simple add methods that we can apply into the collection array list collection. So we add 3 Oracle Java 4, that means the array list collection AR is loaded here. Now the vector, we want to create a vector V. So initialize the vector, create this is a default vector constructor that you can call. Initially the size is 10. We do not have any elements right now. You can add V dot add 3, 4, 5 or whatever you can do fine, no issue. Now after that, if you call this method, the add all method is defined in the collection framework, collection class actually is a method, but it is implemented in vector class for that. So here add all and passing this ARR, then what will happen, it basically if the vector V contains initially some elements, then all the elements which are here in this collection will be added after that. So this basically shows how appending can be done. Other way also again you can do, you can recall there is one constructor where an argument can be a collection. So, if you do that, then initially a vector can be created with a collection of elements in it. So, this ARR can be passed as an argument here, and you can write this, you can call this vector constructor, so that it will basically initialize with these array elements into it. So, these are the different way that you can do, and you can also study practice this program you can modify and you can run it to understand how it works for you. So, these are the different way that the insertion operation or the elements can be added into a vector. Now, let us come to the discussion of deletion operation. So, it is just opposite to the insertion, it is basically removing. There are many methods. For example, you already know clear method. So, if you can call clear method for a collection, it will basically delete all the existing element into that collection. It is an array list or some arrays or whatever it is there. So, that method is defined in class collection, and every collection class has implemented them. So, vector also has implementation of this one. Now, so clean is the one method I just remember. In addition to the clean, there are many other methods also. This table lists the different methods for deletion operation, and the name of the method, actually there is a one what is called the criticism about this vector class is that all the name of the method is very big, insert element at, remove all elements like. So, some programmer may not like that the name of the method in an defined classes will be so large like, but it has certain pedagogical issue. If you give the name of the method a little bit with more number of characters, it basically gives certain advantage to you, that understand that what method does for you. So, remove all elements by the name itself, you can understand what it does for you. It basically just like a clean operation. So, this is equivalent to the clean. Now, another operation, remove element passing an argument object. So, if you can pass the object, then it will basically search whether the object present there or not. If it present, then particular element with its first occurrence will be removed. Then remove element at. Now, in this case you can pass an index. So, at a particular location, if you want to remove a particular element, then you can call this. So, these are the few standard methods, those are defined in vector class to perform the deletion operation on the vector. Now, this is a very simple example again, so that how we can perform the deletion. So, now this part of the code is as usual, you have to create a vector first, then add some elements into it, whatever the elements you want. I have created here around 5 elements into that, and then we call the v dot clear, it is a remove all, actually remove all equivalent. You can again, instead of this method, you can v dot remove all elements also you can, and you can see. And after this, if you can print, it will not print, it will basically it will clean everything. So, this does not print any element. So, null will be printed here. So, this is a very simple, but it is very little bit risky method, because it will clean, and once you delete it, you will not be able to recover it. Anyway, any remove or deletion operation is like this only, removing after this thing, there is no way to get the back the same element again. And this is the one another example. So, this is a deletion, and deletion from a particular location. So, you can mention the index. So, mentioning the index, that is the one convenient way to remove a particular remove an element from a particular location. So, this example demonstrate how you can do that. Now, this is as usual the code to create a vector first, and then you see remove elements at. So, this index is 0. So, in this case, so this is basically the index at 0. So, this will be removed, and it will print after removing this one, it will print rest of the elements. Now, this is another remove elements, but passing the arguments as the object is Japan. So, in this vector, this one is present here. So, it will remove the element, and then after removing, if you want to print, it will print all the elements except Japan. So, this is the way that the different ways that the deletion operation can be done on vector. And this is another example where you can see you can delete elements from a vector, but not all elements. It is basically filter element. So, how the filter element can be done? So, it is called you can say that okay, some set of elements should be retained there, except all those elements, other elements will be removed. So, this is the one example that you can see, deletion of common elements from a vector. It is just like intersection sort of things, it is like that. Now, let us first see the example, then I can explain it. Just let us create two vectors, one is vec and another is that vec retain. That means, you want to remove some elements which are there in this, but retaining all the elements which are here in this one. Now, we create initially the vec of size 7 and this is the vec retain of size 4. Now, we add 7 elements into this vec. So, this is basically adding. So, 7 elements are stored here. And so, we have created the first vector vec. The next set of vectors are vec retain. So, we can create this vec retain is adding some elements here. Let us add 4 elements or 3 elements we have added here. So, this basically loading the vector retain. So, 5 3 2. Now, if we call this method, you can understand what it returns. It basically it will remove all the elements from the vec, but not the common elements that is there, that is 5 3 2 will be retained there, and except this 5 3 2 all the vectors, all the elements in this vector will be removed. So, this is the simple way that the common element can be removed. Common element in a vector can be removed from other vector like this one. And this is another method by which you can scan this. So, for the sake of difference, I have used a different way the vector can be printed. This is another way using, it is called the iterator. In one example, previous one example you have learned about using enumerator. The iterator is also one way that it can iterate, that means scan or traverse the entire vector. So, has next, and this next is basically has next, check that whether we reach at the end, and if we do not reach, it will go and then at the current element will be printed as each time it traverse from starting element to the last element like this. So, this basically shows about the removal operations from the vector, and there are few more operations is called accessing elements from a vector from different there. There are couple of methods are there. I have listed very commonly used methods, those are defined for the class vector. Here for example, capacity you are already familiar to, then contents also we have already discussed, element at also sometime we have discussed about, past element, index of, the by name actually you know exactly if you can call a method for this for a particular vector objects and what it does, and automatically argument you can cast. So, my advice is that you can run the programs of your own to exercise how all those methods works for you. It is easy. So, you have to create vector first, add the vector with some initial element and then apply all those method, and you can see how it results. So, you have to print, you can use any iterator or enumerator or in simple system.out.println to print v after each operation. For example, if you call is empty, so if you can check is empty returns true boolean value. So, whether true means it basically empty, false means it is not, that it contains some element like this one. So, all those methods are very simple, easy to learn, easy to use, easy to apply in your program, and you can see it. I just left as an exercise because time will not permit to give illustration for each methods and discuss it, but it is easy. So, you can try, you can burn your hand and then you can see it. Now, I just want to give one more specific example about searching an element. So, contents method we have already discussed about. So, this example shows how the content method you can apply in this here. So, this is the usual code. So, here these are the usual code for creating a vector and loading it, and then use v contents. So, this is one, you check that whether this is there. So, it return true or false depending on if the element present there or not, and then it will write. So, this is a very pretty simple example. Like this, you can exercise all the methods in this class and then check that how they work for you. So, here again searching over the entire list is a, but searching can be done with a specific elements here. Now, here searching at a last element or index element like this one, for example, here this method is very interesting to see the last index of 2. Now, here in this particular vector that you have created here, 2 occurs 2 times here. For example, this is the first location, second, and then again fourth location it is there. Now, you can call last index of method, that means it will, if you just contents, it will basically check the first occurrence of the element. So, if you say v dot contents 2, it will basically find this one, but if you say last index of 2, so that means from the bottom, which is the last occurrence of the element having a particular value, it can basically search and return these things. So, this is the one use, that a specific element location, searching at a particular location also can be carried out. So, these are searching up, and then like searching you can do some setting elements also, it is called the replacement, and this example shows the how the replacement of a particular element can be done here. For example, the method set element at can be used. So, it basically says that index and this is basically 1. So, it is set 4 at the place of, it is basically index start from 0 to, that is why the set at the location 2 actually. So, it basically this method replace the element which is presently at the location or index 1 by 4, and after executing this method, if you can print this, you can see this element will be replaced by 4. And there are few more bulk operations that you can carry, you can apply on this vector class. I have listed the methods here. This is the clone method, basically it will make a duplicate of an existing vector, copy into a collection object array, object of any type of array you can create, and then you can copy that. This is same as clone. Enumeration elements, so all the elements can be enumerated. If you have the familiarity of the enumeration, you can understand. So, if the 7 elements say Monday, Tuesday, Sunday like this one, and they can be enumerated type, and then all element can be converted to string. So, it is another method. Trim to size, if you can reduce the vector into a particular size, deleting some element, also the different methods is called the bulk operation. Now, let us quickly visit some examples in this category, so that you can understand. So, cloning a vector, this operation you create a vector v and another, you define another v clone and initialize this vector and then call this v clone, that means it will basically duplicate of all the elements and copy into this vector. So, this is the clone operation that can be performed on a vector class, and copying a vector into an array collection actually. So, here is an example, you create a vector and then you create an array of elements. So, it is an array of integers and then copy into array, that means this vector will be copied into this array. So, this is another copy, it is just like clone method, and this is the printing of the array or printing of the vector also you can do in the usual way. And then you can check whether the two vectors are equal or not. So, there is a method, the method is called equals method. So, here we create two vectors, and in this case as you say two vectors are almost equal, same, either they are in order or they contain the same element. So, it basically check it and then print accordingly if they contain the same set of elements or not. Then string representation, two string method you can use. So, this is basically creating a vector and then two string method, that means all the elements those are there, you will be converting the string and then print. And this is the last method, hash code. This basically you create a vector. Now, regarding hashing we will discuss later on in details. So, hash code is basically is a encryption form. So, all the elements will be encrypted and then encrypted version, which basically is very difficult to difficult to understand that for which this is the number like this one. So, the hash code we will discuss in details later on, but here for a vector class you can call the hash code method to encrypt all the elements. So, this is the method that can be called as a the bulk operation. Now, we have discussed about many methods, those are very common to use in vector. I hope that you have little bit studied about the vector class. If you want to study more about it, there are link I have given. This is the one link, all the program that we have used in this, in addition few more programs also you can find it there. And for details about the vector class you can go to the link. This is the official websites of the Oracle sets. So, tutorial, and go to the vector class, you can find details about each methods that is there in the vector class with some illustration. Very good materials, and moreover if this book is good. So, you can follow this book for studying. Okay, thank you.